First of all, thanks for coming to this session in which we will discuss serverless Java. I know it's a tough spot. I mean, right after lunch, we all want to have a short nap and so on, but thanks for being here. So my name is David DELABASSEE. I work at Oracle. I'm used to spend a lot of time on Java EE and Jakarta EE, but since a few months, I'm part of the serverless team at Oracle. So that's what we're going to discuss today. So serverless Java in action. I could also... We don't hear you very well. Yeah, OK. Is it better? 1, 2, 1, 2. Yeah, it should work. No? Can you hear me at the back? Yep. You should move to the back. No, I'm joking. So serverless Java in action. So I could also have titled this session, Where is Java in the serverless space? Because clearly today, Java, well, is being used in the serverless space, but we will see that things could be better than that. So I work at Oracle, as I mentioned, and before we dive into the session, I want to spend like 1 minute on talking about where I'm coming from, Belgium, because that's a very small country. That's a country that is stuck between Germany and France. In terms of population, it's, I think, 2 times smaller than Romania, and in terms of size, it's 7 or 8 times smaller than Romania. So it's a very teeny country. Having said that, we do have in Belgium one thing that is very famous. That's the Belgian cuisine, the Belgian food. So what do we have in terms of food in Belgium? We have Belgian beers. Over 1,600 different types of beer. And in fact, the UNESCO, so the cultural branch of the United Nations, have put the Belgian beers in their cultural heritage list. So that's something which is quite important. We then have Belgian chocolates. We produce over 22 kilograms of chocolate per year per inhabitant, of the best chocolate in the world. We then have this. Anybody has a guess what this is? No, not French fries. Belgian fries. So clearly, that's a very sensitive topic. So there is an ongoing battle between France and Belgium for ownerships of fries. And if you don't believe me, just check the Wikipedia page for fries, and you see, there is a whole section about that battle, and clearly we have all the arguments to prove that fries are coming from Belgium and not from France. Finally, we have this, the Brussels sprout. Anybody enjoy the Brussels sprout? No? Good. And let me share a theory. I'm pretty sure that the Brussels sprouts are not coming from Brussels, not even from Belgium, but are coming from France. So those are... No, but I'm serious. So those are the French sprouts. Finally, Belgium is also the land of surrealism. If you don't believe me, just fly with a Brussels airline, and if you fly with them, you can get fries during your flight. And again, if you don't believe me, just check what they are claiming. Yes, fries were actually invented in Belgium. OK, enough about the Belgian cuisine, and let's talk about serverless. So first, I will set the context so that we are all on the same page, and then we'll switch gear and talk about serverless Java, and then we'll see that in action. So serverless, function as a services. So first, at the heart of any serverless platform, we have a function. A function is basically a very well-delimited piece of code that will get something in input. It will produce something in output. So it gets something that triggers the function. It does its job, and it will produce an output. Now, well, it's not a function as we might have in mathematics in the sense that the function might also have some side effect. Like, for example, putting something in a queue. That would be a side effect. So we have this notion of a function. So the function, a well-delimited piece of code, it will perform a job, just one job. And then we have this as a services piece. So that's basically the compute element on which your function will run on. And we can clearly distinguish 2 types of role. There's the FaaS platform users. So typically you, the developer, who will write function. And then you will pass your function to a FaaS platform. And the second role would be the FaaS platform operator or provider. And the FaaS platform provider has basically to make sure that everything runs, so that the platform is rightly provisioned to serve all the requests that it has. It has to make sure that the platform is rightly maintained, patched, and so on and so on. And you, at the end of the day, as a developer, will just have to focus on writing function. You don't have to take care about the platform itself, given that you are using someone else's platform. So the function, it's really the fundamental unit within any serverless platform. The function is basically the basic unit of design, the basic unit of deployment, but also the basic unit of scaling and billing. So why would you want to go toward a serverless model? There are multiple reasons. Now, I'm not saying that a serverless platform is a silver bullet that will fit any kind of scenario. No, clearly. I mean, there are some given use cases where it makes sense to go toward a serverless architecture, but there are some use cases where it doesn't make sense. Typically, whenever you have something that is highly event-driven, that might be a very good use case for a serverless platform. So, multiple reasons why you might want to go toward a serverless platform. So first, there's no management. Given that you are using someone else's server, you are using the FaaS platform, you don't have to manage the server, so you don't have to provision those servers, you don't have to patch them, and so on and so on. Scaling. Functions, most of the time are very well-bounded and very short-lived. So you will invoke a function, the function will do its job, it will live for 100 milliseconds, 200 milliseconds, maybe 1 second, maybe 5 seconds, and then it will die. So by nature, function should be stateless, meaning that if you need to hold some kind of state, you shouldn't do that within the function, you should do that outside of the function. And functions are ephemeral. That really helps when it comes to scaling. Billing. Serverless platform also allows to innovate when it comes to billing. So given that we have very short-lived piece of code that will run, the FaaS platform provider can increase the density, and it can also change the way typically we are charged for. Most of the time, whenever you are using a FaaS platform, you will only get charged whenever your function is consuming some resources, whenever your function is running. Meaning that if the function doesn't run, you will not have to pay for anything. And last but not least, let's not forget all the deployment aspect. And I will come back to that later when we're talking about serverless Java. So serverless today, it's a pretty young space. I mean, it's 4 or 5 years old, not more than that. But clearly, there are a lot of momentums regarding serverless. So some are claiming that serverless adoption is on par with container adoption. I don't know, but I mean, some are even pretending that serverless are basically killing containers. Again, that's a pretty bold claim. But let's not go into that. We know for sure that serverless is really hot those days. Now, let's switch gear and talk about serverless Java. So, we know for sure that Java is very popular. So this is something that comes from GitHub from last week. And basically, you see that Java is the second most used language on GitHub by looking at the number of contributors. If you also look at the number of repositories, we have the same statistic. JavaScript on GitHub is first, and then Java is second. So Java is very popular. If you look at this RedMonk study that they are doing every now and then, you see that Java is also very popular. So Java is second, and JavaScript is first in this case. If you look at the TIOB index, Java is first. So we know for sure that Java is very popular. So now the question, what about Java in the serverless space? So it's a pretty young space. We don't have a lot of metrics, but the only few metrics that we have are not really that great when it comes to Java adoption within the serverless space. So this is a metric that is coming from a serverless framework study. So basically, the serverless frameworks guy asked their community, okay, which language are you using to develop function? And well, you see that we have this big green arc around, that's node 6, 70%. If you add that to the purple one, which is node 4, more than 5%. Basically, when it comes to the serverless frameworks, more than 75% are using Node, so basically JavaScript. Next, there's Python 3, 9%. Python 2 is another 2%, so 10% are using Python, and so on and so on. And if you look at Java, so where is Java? So we have Java 8, that's the yellow box there. It's just below 5%. So it's clearly not a lot. Not only that, the trend doesn't really look good. So the first question was, what are you using today to develop your function, your serverless function? And the next question is, what do you plan to use? And well, you see that basically Python 3 is increasing, Python 2 is decreasing, but that's okay given the increase of Python 3. Node 6 is not even on this graph. It's way above, so again, Node is leading the pack. And you see that we have this orange line, which is kind of flat, and that is Java 8, around 5%. So that's really not a lot. You can also see at the right bottom that we have Go, and Go is very low, but it's increasing at a rapid pace. So clearly, the only metrics that we have aren't that bright for Java usage within the serverless space. So how can we explain that? Well, first, we might want to look at the landscape. So if we look at the historical landscape, by historical, I mean the three large cloud providers that do provide today a serverless offering. That's Amazon, Azure, and Google. Well, only Amazon is really providing Java support. Azure has some kind of preview Java support, and Google Cloud Function at this day don't have Java support. So clearly that might explain why Java is not yet popular in that space. Something else that might explain that is this quote from James Governors from Redmond that basically say that startups tend to use the cool technology of the day, and when they become mature, when they have to scale, they are switching to Java. So given that serverless is pretty new, maybe, well, those users are still using the cool technology of the day, like Node, and maybe at some point in time they will switch to Java. That's just a guess, I mean. Now, it might also be that Java is just not a good candidate for serverless function. At the beginning, serverless functions were used as some kind of glue code. So you had a services there, and you had another services there, and you were gluing them together using a function. So maybe Java is not a good fit for that use case. Given that functions are short-lived by nature, maybe Java is not the right language for writing a short-lived application. You know that Java has been written for a long-lived application when the JIT start to kick in to optimize the code and so on. So maybe for pure short-lived application, Java is not a good fit. And maybe just the patterns that we are using within the serverless space, there's a mismatch between that and what we are doing on the Java side. So maybe that might explain why Java is not popular within that space. So let's look at some of the patterns within the serverless space that we think are important when it comes to Java. So first, as Java developers, we want to keep writing plain old Java code. We also want to keep using the tool that we have been using for years. So that's something which is important. I told you that functions are very short-lived, so they have a very well-limited scope. They just have one task to perform. But we think that there are use cases where it makes sense to use a serverless function for writing more complex applications. So we will look at that. Low latency, high performance, it's a given. That's something that Java needs to provide for serverless functions. So that's something that we'll have to consider. And finally, with Java, we live in a very rich ecosystem. So we'll see how we can tackle that within the serverless space. So I work within the serverless team at Oracle, and Oracle is one of the largest contributors to FN project, which is an open source FaaS platform. So Oracle right now is building its managed FaaS platform offering that will be launched early next year. And technically, it's based on FN. What I'm going to discuss today is just FN, the open source project, so something that you can clone from GitHub and use it by yourself. So there's nothing specific to Oracle within what I'm going to discuss today. So FN is an open source container native serverless platform. It's container native in the sense that you will see through my presentation and demos that FN is heavily relying on containers. Basically, a function in FN is just a container. Now, as a user, you don't have to know that. As a user, you just want to write, if you're a Java developer, you want to write Java code, and all the tooling will make sure that this Java code will be exposed as a serverless function using a container. So FN is open source, Apache v2 license. GitHub.com/FN project is the organization where you can find all the code. And given that everything is open source, you can take FN and run it within a different cloud provider. So you can take FN and run it on top of, let's say, Amazon or any kind of cloud provider. There's clearly nothing specific to Oracle within Project FN. You can also run it within your own data centers. There are use cases where it makes sense. So remember what I said at the beginning. So when it comes to serverless, there are two types of roles. There's the FaaS platform user and the FaaS platform provider. So of course, if you are going to run FN on premises, so in your own data centers, that basically means that you will have to cope with the two roles. So you will be the user, but also the provider. So there is a cost to that. I mean, you will have to make sure that you manage the platform, that you provision the platform, and so on. But if you understand that, and there are use cases where it makes sense. Typically, if you need to comply with some local regulation where the data cannot leave the country or some geographical region and so on, maybe you cannot rely on an American cloud provider, those kind of things. So there are use cases where it makes sense to run your own FaaS platform. But if you do that, obviously there's a cost. And last but not least, given that everything is open source, you can just take FN and run it on your laptop. That's very convenient for development. And that's what I'm going to do today. So I have FN running on my laptop, and from time to time I will switch to a remote FN running within Oracle Cloud. Technically, FN is written in Go. It's an infrastructure project, such as Docker or Kubernetes. So that means that we do support writing Go function, but obviously that's not the topic of today. So today I will just talking about Java function. So Java is clearly a first-class citizen on top of FN. So we do provide a Java FDK. In fact, we are providing multiple FDK, so a function development kit. So a function development kit is a piece of, it's basically a kit that helps you to write a function. So for the Java FDK, we are providing an optimized build image and an optimized runtime image. The thing is that you want to use a different image to build your function and to run your function. To run your function, you want the image to be as small as possible. But obviously, to build your function, you need to have a little bit more things to actually build it, like the GDK, for example. So we are providing those two images. You don't have to deal with that. We are providing, through the GDK, JUnit support. You will see that the FDK allows you to keep using Maven, because at the end of the day, Java function within FN is just a Maven project, and so on and so on. So let's look at FN, how it works with the first demo. Sorry for that. Display. Yep. Okay, let's zoom a little bit. So what I have running here is FN on my machine. So the first thing that I want to do, I want to write a function. So for that, I can use the FN CLI. FN init, so I want to bootstrap a function, and I need to specify which runtime I want to use. So I could say Go or Node or whatever, but obviously, given that we're talking about Java, we'll use the Java runtime. And we then need to give our function a name. I'm very good at giving very obvious names, so my function will be called Duke. And now if we go to the Duke directory, we have a few files which have been created. So first, there's a func.yaml. So if we look at that file, that's basically a file that contains some metadata for the function, like which version are we using, what is the name of the function, the version of the function, the runtime, it's Java, which build image we want to use, which run image we want to use. And then there's this, the command. And the command is basically our entry point to the function. And this is the class of the function. This is the class of the Java function. And this is the method within that Java class, which will be our function. So what we have here is also a POM. So basically what we have here is just a Maven project. So that means that I can use my ID. So I will this is the function which has been generated for us. So it's basically a simple LOL function that we can start to hack. So it's pretty basic. So this is This is the method that I was talking about. So this is the actual serverless function. In this case, just get a string, and it will produce an output. So what can we do? Well, first, if we go here, we see that we have a JUnit harness test that is basically doing some black box testing for the function. So given that we have a Maven project, we can just test the function. So Maven test. And well, the tests are obviously working. Obviously, I can change my function. So, for example, so here, this is very basic. We get a string and we produce a string. What we can say, for example, let's see. We can say that, for example, we have a class person. Private. So a person has a name and a first name, right? I need a constructor. I need a default constructor, and I need, this is very teeny, okay. Getter and setter. So this is basically just a plain old Java object there. And also, if you look at the function itself that we're running, there's nothing specific to FN here. There's no interface there. I mean, it's just plain old Java object. So what we can do, for example, we can say that, well, instead of getting a string here, we get a person type. So now my function is getting a person type. So obviously, I need to, whenever I'm invoking my function, so I need to invoke my function. So something I forgot to mention. If I want to invoke my function, obviously I need to deploy it. I will deploy it here locally. So fn deploy. I need to specify an app. So an app is just a grouping of functions. So let's give it a very obvious name like cluj. And then I specify which function I want to deploy. Given that I'm in the directory of the function, I don't have to specify the name. And just to see what's happening behind the scene, I will add a verbose first. So you see that behind the scenes, we are using Docker to basically wrap your Java code as a function. And it doesn't work. Is empty. Where's that? Yeah, it doesn't work because I've saved that guy, and obviously input doesn't have is empty anymore. So let's save that, and let's say that instead of producing input, we want to just output the first name of the user. Okay. So my function is being built. And it failed. Did you see why it failed? Well, the tests are failing, obviously. So whenever we build a function, given that we have a JUnit test for the function, we're also testing the function. So I need to fix my test. I know you would say that. Well, don't do that at home. But I don't have, I mean, given the time, I don't have to, each time I change a function, I don't have the time to fix the test. But again, don't do that at home. That's very tricky. So let's try to deploy it again. So my function is built. What happened here is that my function is being pushed to a container registry. And that container registry will be used by my FN server to basically, whenever my function is invoked, to fetch the right image for that function. So now so my function is built and deployed to the registry. Now if I look at the FN, so I want to list the function within the cluj application and have the Duke function. So now I can invoke that function. The thing is that here, I'm saying that my function is basically getting a person type. And obviously, so if I invoke that function, I need to make sure that I do provide that type. For that, I'm going to use just JSON. So we're talking about a person. that has a name and that has a first name. So this is the payload that I'm going to use and that I'm going to send to my function. So for that, I can just pipe my payload to my function directly. So cat in, now I need to pipe. So I'm going to use the fn, another CLI command, fn invoke. So I want to invoke the Duke function within the Cluj application. So that's why I'm doing fn invoke application and then function. So let's see what's happening. And so you see here, what I have in return is basically hello David. And if we go back to the Java code, you see that on the Java side, I didn't have to deal with JSON. I mean, the coercion between JSON document that is being passed to my function to Java object here is directly handled by the Java FDK. So that's one of the things that the Java FDK provides. Obviously, we are doing that in input, but also in output. What you might have also noticed is that the first time I was invoking that function, it was a bit slow. Why? Because that function wasn't hot on my FN server. So my FN server, which happened to run locally, had to fetch the function from the repository, and it had to start a container. But obviously, the next time I invoke that function, so here it's not hot, but here, if I invoke it again, you see that we basically went from over 1 second to, for the second invocation, below 100 milliseconds. Why? Because the function is hot within that FN server. And obviously, until my function is being kept hot, I will have very, very good startup time. Having said that, my FN server is running locally. So obviously, at the end of the day, you want to deploy your serverless function within a FaaS platform, a remote managed FaaS platform. For that, you just need to switch context. So I never know in which order the command is, so FN, obviously that was the other one, fn use context. So I was using the local context, and this time I want to use the Oracle Cloud infrastructure context. So fn use context allows me to switch to a different context. And this one is running within a data center in the US. So now, if I deploy my function again, it will not be deployed to my local FN server, but it will be deployed to that FN platform running within Oracle Cloud. And I also have to push the Docker image of my function to Orchestrating. In this case, I'm just using Docker Hub, so my own private Docker Hub repo. So now I have this serverless function, which is deployed within Oracle Cloud. So I can time the invocation again. That should work, so time. So now it takes a bit more time because we are not doing a local invocation, but we are doing a remote invocation. So the first time is, 1,700 milliseconds. The second time, it should be a little bit faster, 800 milliseconds, but I still have to go through the ocean to basically get the result of that function. 600 milliseconds, and so on. So that's basically in a nutshell how, as a Java developers, you can write serverless Java function using FN. So first you see that we are just using Maven, so you can import your dependency through Maven. You can basically keep using what you have been doing for years. I'm just using my standard IDE. There's nothing specific when it comes to developing a serverless function with FN. In this example, I have also used the FDK for providing input coercion. Obviously, I can also use the FDK to provide input and output coercion, those kind of things. That's something that is provided by the Java FDK. So if we look back at the patterns, plain old Java, yes, I mean, you can write serverless Java function using plain old Java, and using your existing tool chain. I mean, I've used IntelliJ and Maven, so you can integrate with whatever you are using today. Now, the next question is, what about the ability to build complex application? And for that, the Java FDK provide FN flow. So at the beginning, I told you that whenever you have to hold the state, you shouldn't do that within the function itself. Having said that, there are use cases where it makes sense to hold the state within a function. And that's typically whenever you have a function that will orchestrate multiple functions together. So the idea is that you have a main function that will invoke a first function. It will wait for the result. Once it has the result, it will invoke, based on the result, another function. And maybe that other function will fail because we have to go through the network. And the main function will have to act accordingly. So basically, this is really about orchestration of function. For that, in FN, we have Flow, and we have a Java implementation of that, the FN Flow API. So the Flow API is basically like the completion stage API of Java IC. So in Java IC, we have this completion stage API that deals with asynchronous tasks. So this API allows you to define asynchronous tasks. And you can also define, using the API, a pipeline execution. So I invoke that asynchronous task, and whenever that asynchronous task is done, I want to invoke another asynchronous task, and so on and so on. And all of that is done in async fashion. The FN Flow API is exactly the same. The only difference is that the completion stage API, everything happens within the same process. The FN Flow, given that we're invoking function, everything is distributed. So we're invoking a function, we wait for the result in an async fashion, and once we have the result, we invoke another function. But obviously, that other function will likely be running on a different FN server. But that's not an issue, given that everything is handled by the API. So that's not something that you have to deal by yourself. So sorry. I switched slide too quickly. So to illustrate that, I have a demo. Typical travel scenario demo. So the idea of that demo is that we have the main function, the travel agency demo, and that functions will be used to provide recommendation to a user. So a user come in and we would like to give him a few recommendations where he might want to travel to. So for that, we will first invoke another remote function that will give us just some random destination. And for all destinations that we're going to suggest, we also want to add some weather information and also some quoting information. So we would like to give the user a number of destinations with some weather forecast and some pricing information. That's the main idea of the travel agency function. So let's look at that function running. Oops. So let's see which app. So first, let's switch context. So if I use context local, let's look at which app I have. And I have the bottom application, which is called Voyage. And if we look at the function which we have there, so in that application, we have 4 functions. So destination recommendation will give us some suggestion where the user might want to travel to. Quotation will be used for adding some quotation to a given destination. And weather forecast will be used to add some weather information to a destination. And finally, we have the rec function. That's the main function which will provide recommendations. So basically, that's the function we'll have to provide and do the orchestration of those functions. So let's look at a demo. So let's say that we want to provide like 7 destinations for the user. So for that, I need to invoke the Voyage app, and within that application, I need to invoke the rec, so the recommendation function. The thing is that it's not highly visible, so it's not highly visual. So I have a small tool here. Let me kill that guy, and let's use Chrome. That we can use to see what's happening behind the scenes. Oops. So I will first invoke that function, and if everything goes well, we can see what's happening here. So first we are invoking, so this is where we are invoking the destination function. So we have 7 destinations. For all the destinations, we are invoking in an async fashion first the forecast function. You see that we had some red box. This is basically the function that is failing, so this is done on purpose. So we have some random timeout within the function to make sure that some of them are failing. And finally, once we have the destination, we are also invoking the pricing function to add some pricing information. And again, you see that some of them are failing. So this one failed, so we throw an exception. That one was OK. This one failed, and so on and so on. This is OK, because the main function is basically dealing with a remote exception. The thing is that we can send a destination to user if we don't have if we don't have the weather forecast. But obviously, if we can't give him some pricing information, we don't want to suggest him to go there. That basically means that we won't be able to sell that ticket. So if we look at what we have here, so we have 2 destinations, so that's okay. So Chicago, we have some weather for Chicago, and then San Francisco, and we also have some weather for San Francisco. And this is purely random. So if I run it again, I will have a different result because of the random timeout. So for example, here we have only 3 weather forecasts, and when it comes to pricing, we still have only 2 that we are able to get the price to. But you see that, for example, this time, Venice, we don't have any weather forecast to provide. That's okay. And the same is true for LA, we don't have any weather forecast. So that's basically the FNFlow API in action. If you know how to use the completion stage API, it's exactly the same. So, for example, we are dealing with exception, with an exceptionally composed, those kind of things. So if you know how to use the completion stage API, you will you will get started very quickly with the FNFlow API. We basically have the same construct. So if we go back to the patterns, ability to build complex application, yes, that's something that we can do using serverless Java. Again, we're just talking about orchestrating multiple functions together. Don't use the Flow API to do everything. If you have to orchestrate function, the Flow API is a very good candidate for that. Now, let's quickly talk about low latency for serverless function running within containers, given that under the hood, at the end of the day, we are just using containers. So first, Java needs to respect the environment it runs in. We're running within containers, so Java should be aware that it runs within a container. Startup should be fast. And also, we want to run in the smallest possible image. There are multiple reasons why we want to do that. So first, let's talk about respecting resource constraint. Well, in a nutshell, if you have been following the evolution of Java since Java 8, you will see that we are constantly adding features and fixing capability of the Java platform to make sure that it can run well within containers. Like, for example, in the early days, whenever you were asking Java to get the memory statistics, you were getting the memory statistics from the host, not from the container, because Java had no idea that it was running within the container. This is fixed. So we are fixing basically, and we are improving how Java runs within containers. And from time to time, you can also see features that might also be useful for Java running within container, or maybe possibly for serverless function. Like we have this new epsilon garbage collector in JDK 11, which is just an experimentation, but that's basically a GC that only do allocation. It never deallocate memory. Maybe it might make sense to use that GC for serverless function, because I told you at the beginning that serverless functions are very short-lived. So why should we want to pay the cost of garbage collecting if the function will only live for 200 milliseconds? We just allocate memory, and we know that in 200 or 300 milliseconds, the function will die. So we don't have to pay that extra cost. Start fast. There are multiple techniques that we can use to make sure that Java starts as quickly as possible. CDS, class data sharing. Anybody is using CDS? Anybody knows what CDS is? No? So CDS is something that we have since Java 5. So basically the idea at that time is that whenever you run a Java application, the JVM has to basically bring the class into memory. So it has to unpack the jar, it has to check the bytecode, it had to transform the bytecode within a memory representation, and so on. The thing is that you have to do that for a lot of classes. So CDS was about to basically take a snapshot of the in-memory class representation of rt.jar and just put that snapshot with the application. So the next time you start the application, we just bring that in-memory representation directly from disk to memory. So we basically bypass a lot of things. It doesn't matter because those things have been done at build time. So that's what CDS was about. And clearly, CDS is about improving startup time. In Java 10, we have added CDS for applications. So before Java 10, it was only for rt.jar, but now you can also use CDS for your application classes. So Those are just some of the techniques that we can use for improving the startup time of Java-based serverless function. Let's talk about run in small image. We want to make sure that our Java function run within very small image for multiple reasons. One of the reasons is that each time you need to start the Java function, the FN server has to basically bring from the repository that Docker image. Obviously, if your function Docker image weighs 1 gigabyte, you will have to bring 1 gigabyte. So you want to reduce as much as possible the size of your Docker image. That's one reason. Also, from a security point of view, it's always a very good idea to basically reduce as much as you can the potential surface attack of your code. So if you are not using JavaScript within your function, there's no reason why you want to carry those kind of things that are not used anyway. So there are multiple things that we can do to reduce the Docker image of our Java function. The first one that we can use is we can just get rid of all the stuff that we are not using. So with Java 11, we have, well, since Java 9, in fact, we have modularity. So we are jailing. Jailing basically allows you to strip down all the modules that you don't need. So you will have a stripped down version of the GRE with just the modules that you're going to use. And this is a test that I've done. So on the right side, this is a hello world function that is using the Java FDK. So in gray, we have the operating systems, 68 megabytes. In blue, that's basically the GRE, so the Java runtime. So Java 11, the Java runtime, so this is the default Java runtime. It's over 200 megabytes. If you strip down, if you remove, using jailing, all the modules that you don't need, you will fall back to a 40 megabyte GRE. So basically, with jailing, we are reducing the image size of our function from so nearly 300 megabytes to just above 100 megabytes. At the top, the red small flat thing is the function itself with all its dependency. So you see that within the Java space, we have tools that can help us to reduce the size of our Java function. So this is one technique that we can use. Another technique is that we can rely on very small Linux distribution. Typically, we are talking about Alpine and Muscles. So Alpines and Muscles are a highly optimized distribution, around 5 megabytes. So if we can run Java on top of those distribution, we will again reduce the size of our function image. And that's the goal of Project Portola, making sure that Java can run nicely on top of Alpine and Muscles. And we have some metrics regarding that. And well, obviously, if you have a let's say 5 megabyte OS here, the megabyte is let's see the megabyte. Sorry, the operating system 68 megabyte. So you are again saving like 60 megabyte from your image. So that's another technique that we can use. And last but not least, something else that we can use for serverless Java function is use Graal. So Graal is an open source project coming from Oracle Labs, and one of the things that Graal do is basically taking some Java class and turn that into a native executable. So I have an example here of a very basic function. Let's see, where is it? FNLS apps. Yeah, IBAN. So I have an app that is called IBAN, and if I look within that, FNLS. If I look in that application, I do have two functions. So that function is basically the same. One is written using Java 8, and the other one is using, is using Java 8, but compiled to a native code using Graal. So technically, the application only gets a bank account, and it's just checked using IBAN4G, so a dependency that I import through Maven, and make sure that the bank account that we provide is the right account. So to test that function, let's see. I need to have some IBAN. Oops, sorry. So I need to first have a valid bank account. So I'm going to invoke within the IBAN application, IBAN, I think it's Java 8, and I will also time that invocation. And so first, it's a valid, it's a valid bank account. You see that the first time using Java 8, it takes 1,400 milliseconds, so that's quite expensive. Obviously, if we run it again, and let's change the account, you see first that it can validate the account and that it's way faster. Obviously, with a valid account, it's as fast. And this is a valid account, so this is my bank account. So if you want to make sure that it's a valid account, you just wire me some money, and that should work. So I have two implementations of that function, one using Java 8, so that's the one I have here, and I have the same one using Java 8, but this time with Graal. And not found, so yeah, obviously I need to provide the right name. So again, you see, this is a valid account. The startup time was was way faster. But where Graal shines is when we are looking at the size of the image. So let's look at the size of those two functions. So let's grep, I think it's called IBAN. Obviously, that's assuming that I can type. Okay, so IBAN Java 8, 269 megabyte. IBAN SVM, 22 megabyte. So IBAN SVM is basically the operating system and the serverless Java function, which happen to be written using Java, but it's compiled to native executable. So in terms of performance, when we are using Graal, we are on par with native language such as Golang, for example. There are a few limitations when you are using Graal. For example, today Graal is limited to Java 8, so that's why to make a fair comparison, I've used the Java 8 GRE. But still, I mean, you see that whenever we start a function, if we have to bring 269 megabytes from the repository or 22 megabytes from the repository, there is a huge gap. Not only that, in terms of memory within the platform itself, it will also shine. So let's go back to the slides. So low latency, high performance, I think that we do have techniques that we can use to make sure that Java can be used within the serverless space. Now, let's talk about, I couldn't come with a good name, so I have serverless JVM. What I mean by that is that we are living in a very rich ecosystem. I mean, if you just look at Java and the new release cadence, every 6 months we have a new Java release. We also have projects within the ecosystem, such as Graal, which are way different than typical Java development, but still they are very relevant when it comes to using them with Java code. And then Java is more than just the Java language that runs on top of the JVM. There are a bunch of other languages that runs on top of the JVM. So we had a Kotlin session earlier this morning. There's Groovy. There's a bunch of language. So in FN, we had a capability which is called init image that basically allows us to easily cope with that very rich ecosystems. So what I didn't told you when I was doing an init here is that the code that was generated using an init was Java 9 code. So what I can do that Java 8 for a Java 8 pure code, but obviously that's not what we want to do those days. So what we can do, instead of doing runtime, we can specify an init image. And let's say that we want to use Java 11. So, sorry, thank you. So yeah, let me back up a little bit. So when I was doing that, init runtime, that was Java 9. That's the default today in FN. You can switch to Java 8 just by doing Java 8. But those days, obviously, it's all about Java 11. So for that, we have this init image capability. So Java 11 init, and let's call it test 11. So that would be the test 11 function. fn deploy minus app clash, and the function is test 11. And we can add a verbose to see what's happening behind the scene, and obviously, so fn verbose deploy. So right now, I'm building a Java 11 function. So obviously, you see here that we already had some layers from the previous function build that are there, so they are cached. So let's invoke that function first. So it's deploy, the application was clash, and the function is test 11. And obviously, I need to invoke the function. So we'll go through that. But here I'm using fn invoke to invoke the function. Obviously, I can define HTTP triggers if I want to invoke the function using HTTP. I'm just doing that in the interest of time. So let's first look at what this function does. It's basically just an hello world function. The only thing that it does in addition is that it provides additional information like the version of the operating system and so on. Let's look at the code. Test 11, source, and the function is a hello function. So this is my hello function. So the thing, no, this is not my hello function. Yes, hello function, this is, yeah, hello function. Yes. So the thing that is different is that we have this inspect type that just had some additional information. But you see, for example, here that I'm using the var. I think that if we look at the other class, there's also something which is specific to Java. I can't remember if it was Java 9 or Java, where is it? Map of is something I think that was introduced in Java, well, I can't remember if it's 9, 10, or 11. But anyway, you see that clearly we are using the var inference type that is in Java 11. So basically, we are providing the ability to easily switch to different type of Java runtime. And obviously, we can also do that for Java 12. Obviously, Java 12, well, don't use it in production yet. It's not yet ready. But so if we're deploying this function, so test 11, so my function is being deployed. So this is a very simple function where you give it a day and it will pass you something back based on the data that was passed. So let's say that we are Monday. Fn invoke the test 12. So on Monday, you need to get back to work. And on Friday, you can start to prepare the plan for the weekend. So let's look at the code of this function. So test 12. And this is a Java 12 code. So this is the var from Java 11, but the switch with expression that return value is something that is in Java 12 only. I have multiple switch labels here and so on. So basically, I'm just showing here that you have the ability to switch to cope with the rich ecosystem that we are living here in with Java. And finally, I will just conclude with this one. So you can also do this. So fn init image, but this time, we want to use the Kotlin image because fn also supports Kotlin. So if we look this time at this function, this is again a hello world function, but it's written using Kotlin. Not only that, Kotlin test, no, sorry, source test. We also provide Kotlin JUnit test to test your function. And obviously, I can run that function easily using the same way that I was using before. So this is what the init image is about, to basically easily cope with the ecosystem that we're living. So serverless Java, the ability to cope with the rich ecosystem that we have, I think that's a given. So serverless Java, does it have a future? Well, when we're looking at projects such as FN project, we strongly believe that Java has a bright future within the serverless space. Now, to be fair, I've talked about FN, given that I work within the FN team, but there are all additional open source FaaS platforms that support Java. So we clearly believe that Java within the serverless space, we are just at the beginning. And you saw that the platform is also evolving to make sure that it can also fit within that very special environment that is the serverless space. So with that, I hope it's the right one. So I'd like to thank you. I will conclude github.com/fn project, and last but not least, Belgians fries and not French fries. Thanks a lot. If you have any question, I will be here through the day, so just get a hold of me. Thanks again.